Alright, we're going to go through our transcendental functions calculus review today. And we're going to start by just looking at these powers here. A is a constant, x is a variable, n is a constant. So if we have a to the n, that's just a number. So the derivative of a number is a constant, that's 0. If we have x to the n, that's a variable to a constant power. That's where we're going to use our power rule. We bring down the power, then we rewrite the constant or the variable expression and subtract 1 from the power. If the constant is the base and the variable is the exponent, then that's our exponential function. So we rewrite the exponential function and multiply by the natural log of the base. And then of course chain rule on any of these. X to the x, that's where we have to use logarithmic differentiation. It's not a power rule. It doesn't have a constant as an exponent, and it doesn't have a constant as a base, being an exponential function. So we have to use the logarithmic differentiation. I went ahead and put this here, x to the x times 1 plus natural log of x, because we did that in notes earlier. You don't have to have that memorized. I just put that there. So we're going to do this review in two parts. So I'm going to do the derivatives first, and the second part will be the integrals. So let's get started here. We need to take the derivative of y equals 5 times e to the x over 3 e to the x plus 1. You can, of course, take this denominator and make it be times 3 e to the x plus 1 to the negative 1 power and do the product rule. I'm just going to go ahead and do the quotient rule as it's written here. So we start with the denominator. So 3 e to the x plus 1 times the derivative of the numerator. Very simple. 5 e to the x. Minus the numerator, 5 e to the x, times the derivative of our denominator. So we have a 3, derivative of e to the x is e to the x, and then plus 1 goes away. We're going to divide that by 3 e to the x plus 1 squared. Carrying that down, we're going to multiply out our numerator, as always. We get 15 e to the 2x plus 5 e to the x minus 15 e to the 2x. All over 3 to the ex plus 1 squared. Canceling these out right here, this gets canceled with that. We're left with 5 e to the x over 3 e to the x plus 1 squared. Pretty simple. Or at least straightforward, maybe not simple. Next problem, we have y equals 10x cubed times natural log of x. So there we did the quotient rule. Now we're going to do the power rule. So y prime equals the first, 10, x cubed, times the derivative of the second, 1 over x, plus the second, natural log of x, times the derivative of the first, which is 30x squared. Simplifying, we get, let's see, that's going to be 10x squared plus 30x squared, natural log of x. Some might write this as 10x squared times 1 plus 3x, 3 times natural log of x. Both are fine. I don't really care which one. There's not really a preference. Moving on, we see we've got another product rule involving an inverse trig function this time. So let's get going, make sure we know that this is a product rule. We have the first, x to the 1/2 times the derivative of the second, which is 1 over the square root of 1 minus x squared, no chain rule, plus the second, inverse sine of x times the derivative of the first, 1/2, x to the negative 1/2, again, no chain rule. Simplifying this, these are both square roots, so we can put them together. We have the square root of x in the top over 1 minus x squared in the bottom, plus, now remember that this is not a negative exponent, it's the inverse sign. So this is actually going to stay in the top of our fraction. So inverse sine of x over, we have a 2, and we'll put this back in radical form. Then the negative puts it in the denominator, half is the square root, and we get the x. So this one's not pretty, but it's not too bad if we take it step by step. Couple more here. We see that we have inverse trig functions, but that they're subtracted. So we're not going to do anything fancy, no product rule or anything. Just have constant multipliers for both. The first is 4 times. Now remember the cofunctions have a -1 in the top, and then they look just like their cofunction. So cosine is -1 over 1 minus x squared. We have minus 10 over 1 plus x squared. And simplifying, there's nothing fancy, I don't think, in simplifying these. Let's just double check after we rewrite it. And yeah, there's nothing there that I see. All right, our last one is the derivative of 1 minus 3x to the cosine x. They tell us to use logarithmic differentiation, but we would already know that because we have a variable in the bottom and the top. Or in our base and our exponent if you want to be fancy. And we're going to take the log of both sides. Most people won't write this step. Most people will start with bringing that power down in front right away using our logarithmic powers. And that's okay. You can start here on the step without losing any understanding in the problem. Now we're going to take the derivative. On the left, we'll take it implicitly, which is 1 over y dy dx. And then we have our cofunction here that's just normal. We got a product rule, so we'll do the first times the derivative of the second, which is 1 over 1 minus 3x times chain rule, -3. So that's the first part plus the second, where we just rewrite that, times the derivative of the first. Derivative of cosine is negative sine x. Now, when we solve for dy dx, this y we're going to carry over to the other side. And I'm going to go ahead and rewrite that. That is 1 minus 3x to the cosine x. So there's our y. Then we're going to simplify all this. We have -3 cosine x over 1 minus 3x. So that's these three. Is it going to be plus or minus? Let's see. There's a minus, and they're all on the same level, no denominator. So I'm going to write my trig function and then my natural log, and we're good to go.